Right now, as you sit reading this, you are moving, not just spinning with the Earth, not just orbiting the Sun, not just drifting with the solar system around the heart of the Milky Way. You and everything you have ever known are being hurled through space at over 2 million kilometers per hour towards something massive, something invisible, something astronomers cannot fully see, cannot fully measure, and cannot fully explain. They call it the Great Attractor. And for 50 years, it has been quietly dragging our entire galaxy toward a destination hidden behind a wall of stars. Tonight, we go looking for it. The story begins in 1973. Two astronomers, Donald Lyndon Bell and Alan Sandage, were studying the cosmic microwave background, the faint afterglow of the Big Bang that bathes the universe in nearly uniform radiation. But it wasn't perfectly uniform. One side of the sky was slightly hotter, the other slightly cooler. The pattern wasn't random, it was a Doppler shift, the same effect that raises the pitch of an ambulance racing towards you. The Milky Way wasn't sitting still in space, it was moving, and not gently. The data suggested our entire galaxy was barreling through the cosmos at roughly 600 kilometers per second, faster than anything Newton or Einstein had ever predicted for a galaxy of our size. The question was simple and terrifying. What in the universe could possibly pull something as massive as the Milky Way that hard? To grasp the scale of this motion, imagine the Milky Way as a single grain of sand. Now imagine that grain rocketing across an ocean larger than anything on Earth and never slowing down, 600 kilometers every second. In the time it takes you to blink, our galaxy has traveled the distance from New York to Boston. In the span of a single heartbeat, we cross the diameter of the moon. And yet, from inside the Milky Way, we feel absolutely nothing. No wind, no vibration, no sense of motion. The stars look fixed, the constellations look eternal. But beneath that calm illusion, something out there in the dark is reeling us in like a fish on a line. Astronomers needed a name for it. They chose one that was equal parts scientific and ominous: the Great Attractor. In the 1980s, a group of astronomers nicknamed the Seven Samurai set out to map the motion of nearby galaxies. Led by figures like Sandra Faber, Alan Dressler, and David Burstein, they measured hundreds of elliptical galaxies, charting how fast and in what direction each was moving. The results were stunning. It wasn't just the Milky Way being pulled, the Andromeda galaxy was being pulled, the Virgo cluster was being pulled. Thousands of galaxies across hundreds of millions of light years were all streaming in the same direction, toward a single point in the sky in the constellations of Centaurus and Hydra. They called this collective motion the dark flow. Whatever lay at the end of this gravitational river had to be enormous. The mass required to drag so many galaxies so quickly was estimated at tens of thousands of times the mass of the Milky Way, a monster hiding in plain sight. And here is where the mystery deepens. The Great Attractor lies in a region of the sky that astronomers cannot easily observe. It sits directly behind the disk of our own galaxy, behind a thick curtain of stars, dust, and gas that absorbs and scatters visible light. Astronomers call this region the zone of avoidance. For most of human history, it was a blind spot. Roughly 20% of the extragalactic sky is hidden by the Milky Way itself. And by cosmic coincidence, or maybe cosmic cruelty, the very thing dragging us across the universe happens to sit in the worst possible place. Imagine trying to study a distant mountain while standing in a forest fire. The flames between you and the mountain are so bright, so chaotic, that nothing beyond them is visible. That is what astronomers face when they look toward the Great Attractor. But humans are stubborn. If visible light couldn't pierce the zone of avoidance, astronomers would use something else. They turn to radio waves, infrared light, and most importantly, X rays. These wavelengths slip through interstellar dust like sunlight through water. In the 1990s, the Rosé-T X-ray satellite began scanning the hidden sky. Slowly, a picture began to emerge. Behind the curtain of the Milky Way lay something colossal, a massive concentration of galaxies known as the Norma Cluster, sitting roughly 250 million light years away. Around it, more clusters, more streams of matter, a gravitational well so deep that everything within hundreds of millions of light years was sliding toward it. For a moment, astronomers thought they had finally found the Great Attractor, but the numbers still didn't add up. The Norma cluster, as enormous as it was, simply wasn't massive enough to explain the speed at which we were moving. In 2014, a team led by astronomer Brent Tully published a paper that changed our understanding of our place in the cosmos. Using new techniques to measure galactic motion, they didn't just map individual galaxies, they mapped the flows, the currents, the rivers of motion that connect them, and what emerged was breathtaking. The Milky Way, the local group, the Virgo cluster, the Great Attractor itself. They were not separate structures. They were all part of one immense interconnected supercluster, a single cosmic structure spanning over 500 million light years and containing the mass of 100,000 trillion suns. They named it Laniakea, Hawaiian for immeasurable heaven. For the first time in history, we knew our true address in the universe. And the Great Attractor, it turned out, lay near the gravitational center of it all. But Laniakea raised as many questions as it answered, because even with the entire supercluster accounted for, the math still didn't quite work. The Milky Way and its neighbors were moving too fast. Something beyond the Great Attractor, something even further away, seemed to be tugging on us too. Astronomers turned their telescopes outward, deeper, and began to notice something extraordinary. Far beyond the Great Attractor, around 650 million light years from Earth, sat an even larger structure, a monstrous concentration of galaxies known as the Shapley Supercluster. Named after astronomer Harlow Shapley, who first noted its density in 1930, it contains over 8,000 galaxies, the most massive structure in the local universe. And here is the unsettling part. The Great Attractor may not be the destination at all. It may just be a stop along the way. Think about that for a moment. For decades, scientists believed the Great Attractor was the answer, the endpoint, the thing pulling us. But the latest evidence suggests it is more like a waypoint, a gravitational eddy in a much larger current flowing toward Shapley. If true, our galaxy isn't simply being attracted to one massive object, it's caught in a cosmic conveyor belt, sliding inexorably toward the densest concentration of matter within hundreds of millions of light years of Earth, and we will never reach it. The expansion of the universe is accelerating. Dark energy is pushing galaxies apart faster than gravity can pull them together. By the time the Milky Way could have crossed even a fraction of the distance to Shapley, the supercluster will have receded beyond reach. We are falling towards something we will never touch. What exactly is the Great Attractor made of? At its heart appears to be the Norma cluster, a swarm of galaxies bound by gravity, with a giant elliptical galaxy known as ESO 137-001 streaking through its core, trailing a tail of stripped gas hundreds of thousands of light years long. Surrounding Norma are other clusters, Centaurus, Hydra, Pavoindus, each contributing to the gravitational pull. Together, they form a vast structure that astronomers estimate weighs as much as 10,000 Milky Way galaxies. But mass alone doesn't capture the strangeness. The region is also threaded with hot X ray emitting gas, evidence of ongoing collisions and mergers. The Great Attractor isn't a quiet place, it's a cosmic battleground where entire galaxies are being torn apart and recycled into something larger. Some scientists have proposed even stranger possibilities. Could the Great Attractor contain unusual amounts of dark matter, that invisible substance that makes up most of the mass in the universe? Almost certainly yes. Dark matter is the scaffolding on which all large structures hang, and the Great Attractor's gravitational dominance suggests an enormous reservoir of it. Others have wondered whether something more exotic could be at play, a primordial black hole, a defect in spacetime left over from the Big Bang, or perhaps a clue to the controversial idea of dark flow, a theory once proposed by astrophysicist Alexander Kashlinsky, suggesting that galaxies near the edge of the observable universe are being pulled by something outside our cosmic horizon, something we will never directly see. Most cosmologists are skeptical, but the fact that such ideas are even on the table tells you how deep the mystery still runs. The implications stretch beyond astronomy. They touch philosophy. For millennia, humans believed Earth sat at the center of creation. Then Copernicus moved us aside. Galileo demoted us further. Hubble showed us that even the Milky Way was just one galaxy among billions. Now we learn that our galaxy, our supercluster, our neighborhood, all of it is being swept along by forces we cannot fully name toward a destination we cannot fully see. We are not the center, we are not even still, we are passengers riding a tide that began before the first life appeared on Earth and will continue long after the last star burns out, and we only learned about it 50 years ago. In recent years, new surveys have begun peeling back the zone of avoidance even further. The Parkes Radio Telescope in Australia, the South African Meerkat Array, and infrared missions like 2MASS have revealed hundreds of previously unknown galaxies hiding behind the Milky Way's veil. In 2016, astronomers announced the discovery of 883 galaxies in the zone of avoidance, nearly a third of which had never been observed before. Many lie in the direction of the Great Attractor. Each new detection refines the map. Each new galaxy adds another data point. Slowly, painstakingly, the curtain is being pulled aside, and what's emerging is a structure even richer, more tangled, and more massive than anyone first imagined. Future telescopes will only deepen the picture. The Vera C. Rubin Observatory in Chile will conduct the most thorough survey of the southern sky ever attempted. The square kilometer array, when completed, will map hydrogen gas across cosmic distances with unprecedented clarity. The Euclid Space Telescope, launched in 2023, is already charting the geometry of the dark universe. Within a decade, we may finally understand the full shape of the gravitational landscape pulling our galaxy. We may finally see in detail the structures hiding behind the disk. We may even discover that Laniakea itself is just a small part of something even larger, a structure so vast it makes our current understanding look quaint, and yet Even with all this technology, a deeper question remains. Why does the universe look this way at all? Why are galaxies arranged in vast filaments and walls, separated by empty voids? Why do superclusters flow toward other superclusters? The answer, cosmologists believe, lies in the very first moments after the Big Bang, when tiny quantum fluctuations in a near uniform soup of energy were stretched by inflation into the seeds of everything we see. The Great Attractor, in other words, is the descendant of a ripple smaller than an atom, frozen into space-time 13.8 billion years ago. The pull we feel today is the echo of a whisper from the dawn of time. So, where does that leave us? A small planet orbiting a middling star on the edge of a spiral galaxy, inside a local group, inside a supercluster, drifting toward a gravitational anomaly we cannot fully see, which is itself drifting toward a larger structure we may never reach. The Great Attractor is not just an object, it is a reminder that the universe is bigger, stranger, and more dynamic than our daily lives ever suggest. That gravity reaches across hundreds of millions of light years, that entire galaxies move in choreographed currents, that the dark, quiet sky above your head is alive with motion, and we are part of it. Every second of every day we are falling, and we have only just begun to understand where. If this journey through the unseen architecture of the cosmos moved you the way it moves us, take a moment to subscribe. There is so much more out there in the dark, and we are only beginning to find it.